Well, today we're on to lesson 4. We are still working on integers, but right now we're going to be looking at money and debts. So Claire has $54 in her bank account, and a store credits her account with a $10 refund. How much does she now have in the bank? Making sure that you know that a refund means that they're adding. This is a very simple and straightforward problem. We don't need to use any of our integer strategies because she has $54. That is a positive number, it's a positive balance, and we're going to add $10 to that. So that should be fairly obvious that it's $64. Next, May owes the bank. Owes. That means this is a negative number. So I'm going to right now do that because that's where we're starting. Negative 60. She gets $85 for her birthday. Now she's getting that money and it's for her birthday, so I imagine that that's a positive number. So we're going to add positive 85 to that. And she deposits it in her bank. We kind of already assumed that. How much does she now have in the bank? Well, we can start using our rules here that you learned just this lesson. I know before we were using the number line, which if you're more comfortable doing that right now, feel free. But I am going to go ahead and do this because we know the signs are the same, but they're not. Remember, they were the same up here. So we found the sum, right? Find the sum. If the signs are different, find the difference. That's what we're doing right now. We're finding the difference. But of course, we know we're finding the difference of the absolute value of both of those numbers. So the absolute value of negative 60, the distance from 0 is 60. The absolute value of 85, or its distance from 0, is 85. So that means when I actually subtract these, I'm actually going to switch their places because the larger absolute value goes first. Find that difference. 85 minus 60, well, 80 minus 60 is 20. It's 85, so that means it's 25. And now the part that sometimes people forget is that we take the sign from the larger absolute value. The larger absolute value is right here. It's my 85, and that is a positive number. So that means my final answer remains positive at $25. Moving right along. Tyler's overdrawn at the bank. We need to understand that overdrawn means it's negative. So this is a negative number. His brother has $70 more. More means that it's positive. How much money does Tyler's brother have? Okay, well, if we add these two numbers together, we've got negative 180 plus that positive 70. Here we are again. The signs are different. Find the difference. So we're finding the difference. Still, even though we're finding the difference, it's the absolute value. So the absolute value of negative 180 is 180 because it's 180 units away from 0. The absolute value of 70 is 70. Finding the difference, that means I'm subtracting 180 minus 70. Well, 80 minus 70 is 10, so that means it's 110. Now I need to look at the sign of the larger absolute value. That's this line right here. 180 is larger than 70, so therefore the sign that I'm using is negative. So my final answer is negative $110. Next, Andre has $37 in his bank account, and he writes a check for $87. After the check has been cashed, what will the balance show? So he started with positive $37. He writes a check, so that means that money is coming out of his account, so therefore that makes it negative. And I'm going to be adding it, so plus negative 87. And here we are, the signs are different. Find the difference. Isn't it fun? Always have a song to go back to. Okay, so the absolute value of both of these. Absolute value of 37 is 37 because that's how far it is from 0. The absolute value of negative 87 is 87 because it's 87 units from 0. I am finding the difference, so that means I'm going to reverse the order of these. 87 minus 37. Well, 87 and 37 have the same final digit, that's 7. So that means I can just know that it would be increasing or decreasing by 10. So 80 minus 30 would be 50. Again, 7 minus 7, so those are, tell us, indicate that we're going by tens. So it's 50. The only other thing I need to know is what the sign is. Again, that sign is of the larger absolute value, which in this case is negative. So my final answer is negative $50. Next, the table shows 5 transactions and the resulting account balance. So this is what was done, and this was the final balance. Okay. Some numbers are missing, fill in the missing numbers. I think we kind of already assumed that was going to happen. So the balance, this balance therefore goes to the 147, or the negative 147, taking $147 out of that account, leaving it with 53. So that means I'm going to start with this number to figure out what's done to it. So my account balance right now is 53, and it looks like I'm adding 90 to that. So again, straightforward math here, but signs are the same, so we're finding the sum. Isn't it fun? I just love to sing my math songs. Anyway, 53 plus 90. Okay, so we can ignore the 3 for right now and just think about 50 plus 90. 5 plus 9 is 14, so that's 140, plus the other 3, that would give us 143 here. $143. So that's what I'm going to put right here, my 143. Okay. Next, I know that I'm going to be starting with the 143, and that's what's going to happen to it. So I start out with 143, that is positive, and to that I'm going to add negative 120, or negative 229. Sorry about that. So here the signs are different. Find the difference. So therefore I have to find my absolute values of both of these numbers if I'm finding the difference. The absolute value of 143 is 143 because that's how far it is from 0. The absolute value of 229 is of negative 229, sorry about that, is 229. Sorry, I said it backwards there, didn't mean to confuse you. I'm finding the difference, so I'm actually going to reverse out the orders of these two here. So it'll be 229 minus 143. Now, I'm a little more comfortable actually writing this one out as opposed to, using my logic and doing it in my head, just because these numbers are a little messy. So let's go ahead and look at this. I'm going to rewrite it right here, 229 minus 143. Make sure you stack those numbers on top of each other. It's really important that we start, of course, always in the ones position when we start stacking the numbers. So 9 minus 3 is 6. 2 minus 4. Well, I can't do 2 minus 4, so I'm going to borrow over here from the 2, make that a 1, and then I'm left with 12 minus 4. 12 minus 4 is 8, and I've got 1 minus 1, so that's 0. So my answer over here is going to be 86, and then it's just a matter of, is it going to be positive or negative? Remember, the way that we figure that is we look at this row right here, where my absolute values are. 229 is a larger absolute value. 229 started as a negative, so that means my answer is going to be negative 86. Of course, that's money, but when I rewrite it up here, I'm just going to write negative 86. Okay, so this one is a little bit different, this next one, because we're given what I start with, but we're not told what to do here. So let's take a look at this. And if I start with negative 186, I'm going to add something to it. I'm not really sure what right now, so I'm just going to give that a variable of n, and I know it's going to equal 0. Well, I can use some of my strategies here, which I will show you, but hopefully when you glance at this, you know that to get to 0, we need to add the opposites. The opposite of negative 86 is, of course, 86. So my answer should be 86, but just let's make sure that we understand. Let's use those strategies that we know. The opposite of negative 86, or the opposite of minus 86, is to add 86 to both sides. These two cancel. I'm left with n equals 86, which is exactly what we thought it should have been to begin with. There we go. Next problem. Okay, we get to add some fractions. This is fun. Let's not forget our acronym. I love eating apples and avocados. Yummy! Okay, so we know that our acronym stands first for improper fractions. So that means I need to change 5 3/4 to an improper fraction. So 4 times 5 is 20. Add that 3. That gives me 23/4 plus negative 1/4. And if I set up my handy dandy graphic organizer, I did kind of move it over here because I noticed that these are already the same. So I know my least common multiple of 4 and 4 is, of course, 4. Now, even when these problems are easy, I like to use my graphic organizer so that I'm always in the habit of using it. So these, like I said, are both already in fourths. So I'm just going to rewrite the problem here. 23/4 plus negative 1/4. Now remember, when I go up here, I found my least common multiple. I made my equivalent fractions, which I actually already had. So now I'm going to actually add or subtract. In this case, I'm adding 23 plus negative 1. It's really important that you don't forget the negative, because right now, remember, our rules say to find the difference, because these signs are different. So the absolute values of 23 and negative 1 are 23 and 1. Finding the difference of 23 minus 1 is 22. The absolute value that's larger is 23, and that, of course, was a positive. So that means my answer is going to be positive. So positive 22 drops right down to here, and that's 22/4. I can then reduce that. I know that that tiny little 4 is too little to hold up that big giant 22. So 4 goes into 22 5 times with 2 left over, so that's 5 2/4, giving me a final answer of 5 1/2. Oh, that was fun. Okay, let's go on to the next one here. Next, I've got negative 2/3 plus 1/6. Well, I don't need to make them into improper fractions because I don't have any mixed numbers. So I am just going to go, I don't need to do anything with my I. So I'm going to set up my graphic organizer. So next I know I need the least common multiple of 3 and 6. So in other words, what's the lowest number that 3 and 6 are both gazintas for? Well, 3 goes into 6, so that's very helpful because that tells us that therefore the least common multiple is 6. So that means when I rewrite my problem down here for equivalent fractions, I know that both of these numbers on the bottom, or the denominators, need to be 6. So the one that I need to look most closely at would be this one right here. I say to myself, how do I get from 3 to 6? I know I do that by multiplying times, that's multiplication, times 2. Remember, 3 times 2 does give me 6. So therefore I multiply the top number by 2, which is 2 times 2 is 4, and I can, of course, forget that negative sign. This one already has, oops, let me undo that for you, plus 1/6 already has a 6 in its, as its denominator, so I'm just going to bring that down directly as it is. So now I look at those numerators, and I'm going to bring those right up here to actually now do my addition. So that means I'm going to have -4 plus 1. Signs are different. Find the difference. So I get my absolute values of both of these. Absolute value of -4 is 4. Absolute value of +1 is 1. I know that I'm actually going to be subtracting those because the signs are different. 4 minus 1 is 3. I still need to take the sign of my larger absolute value. That would be 4. So therefore the sign is going to be negative. -3. I drop that right down. I've got -3. Denominator remains 6. Now that, of course, is the correct answer, but I should notice that there's a gazinta that 3 and 6 share. The gazinta they share is 3. So if I divide top and bottom by 3 to reduce it, I end up with -3 divided by 3 is 1, divided by 1, -1 over 6 divided by 3 is 2. So the answer is -1/2. So far, so good. Next problem we have is -8/5 plus -3/4. So I'm just going to, again, follow my graphic organizer. I need improper fractions first. These already are both fractions, so I don't need to change them to become improper fractions because they're not mixed numbers. So here I am with my graphic organizer. So the first thing I need to do is find the least common multiple of 5 and 4. So remember, that's the lowest number that both 5 and 4 are gazintas of, or go into. The first number that both 5 and 4 go into is 20. So therefore I'm going to come down here. I know both of my denominators are going to be 20. And before I do anything else, I am going to bring down, both of these are negative. You see that? So I've got negative here and a negative here. So I need to say to myself, how do I get from 5, whoops, I did it again, sorry about that. How do I get from 5, right there, to 20? Well, the way I get from 5 to 20 is to multiply times 4. I know that these are starting to look like they're in the same spot here, these two problems. Make sure that in your notebook, hopefully they're not as close together. I have limited room here on this. So anyway, we've got times 4. 5 times 4 is 20. So I do 8 times 4, which of course is 32. And then I ask myself, how do I get from 4 to 20? I should know that to get from 4 to 20, that I am going to be multiplying times 5. 4 times 5 is 20, so that means 3 times 5 is 15. So I bring that, the numerators right up here. I know I've got -32 plus -15. Now I did insert the parentheses in there. Remember, the parentheses only means that we're separating the negative sign from the addition sign. I know that was confusing some of you. Hopefully it still is not. So here I'm in a position that the signs are the same. Find the sum. So I'm finding the sum of the absolute value of -32 and -15. So that would be 32 plus 15. 30 plus 10 is 40. 2 plus 5 is 7, so I know that's 47. Since the signs were the same, I just keep that same sign. So it's negative 47. Bring that down, that's my numerator, negative 47. My denominator remains 20. So I then have to reduce it because that tiny little 20 can't hold up that big giant 47. So how many times does 20 go into 47? Well, I know 20, 20, that's 40. So that means it goes into, don't forget the negative sign, goes into it 2 times. And then what's left over? Well, 47 minus 40 is going to be 7. And my denominator remains the same. So it's negative 2 and 7/20. So as you see here, if you hopefully already have this in your notes, this is the same method we used earlier in the year when we were simply adding and subtracting fractions, but now we use the same exact rules. We just have to be aware that we carry along those positive and negatives. And we do that by just, addressing it to the numerators. Okay, next. In each diagram, x represents a different value. For each diagram, what is something that is definitely true about the value of x, and what is something that could be true about the value of x? Now, this problem obviously, or it should be obvious, has many different answers. So the examples I'm going to give you here may or may not be the same as your answers, but the important thing is that they should be along the same lines as your answers. If they are not, if you're confused, please be sure to come and see me. Okay, so for A, I see that my x right here, the first thing I notice is that it's between negative 1 and 0. So what I'm going to say for this one is that it's definitely, and I'm just going to abbreviate this here, it's definitely between, well, first of all, it's definitely negative. I'm going to start there. It's definitely negative. And you know what, quite honestly, you could do that for every one of these. Say that it's definitely negative or definitely positive. To the left of 0, always definitely negative. So I'm just going to leave it at that. And then I'm going to say it could, going to abbreviate that as well. So it could be, well, let's see. I can see that it's between negative 1 and 0. I can see that this is probably about halfway, and this is somewhere in between, not exactly in between. So I'm going to say this is probably a third of the way. So that would make it that it could be that x is equal to negative 1/3. Now again, do I know that that's an absolute truth? I do not. But it seems pretty reasonable given, what I can see right here. So there you go. That is part A. Next one. We've got B. So let's see. What do I see here? Well, my x is way over here. So it's clearly to the right of 0. So for B, I'm going to say that it's definitely positive. I could also say that it's definitely larger than 1 because it's to the right of 1. But I'm not going to write that. You can write it down if you'd like. Next thing, what could it be? Well, it could be, let's look at the location of x. X is bigger than 1. So if I'm looking for an actual number, I'm going to say that if I look from here to here, because the same distance is above, that would be half. And clearly this distance is smaller than that. So from here to here, I'm again going to go with the third, and I'm going to say that it could be that x is equal to positive 1 1/3. Again, is that an absolute? No, it is not. It's just what seems logical as I, go through and study where these numbers are. So there you go. That is B. Next, I've got my x is way down here. So again, I'm going to go with the definite. I mean, you can't go wrong with saying if something's definitely positive or definitely negative. It's to the left of 0, so it's definitely negative. And now let's find something that it could be. Okay, what could it be? Well, I think that this one, when I take a look at this one, if I were to go the halfway point, I look at both these distances that, again, I kind of sketched out. It looks like this distance is about equal to that. And so I'm about halfway beyond, like if I'm considering the size of the units, I'm halfway beyond that -1, past the -1 to the left. So it means it's getting smaller. So that means x could be equal to -1 and 1/2. Again, might not be exactly the answer you have. If you are confused, please make sure you come to ask me. Okay, our last problem down here. I've got my x right there on the number line. So it is to the right of 0. I am therefore going to say that it's definitely positive because it's to the right of 0. And what could it be? Well, I'm going to do the same thing I did before. I'm kind of look at the size here. I would say that halfway is here. So it's whoa, I missed something here. I do apologize to you. That says -x. So that means it's the opposite. That negative means opposite. So it's the x is opposite. So if I want this to be positive, which I do, I'm sorry I missed this. I really don't mean to confuse you. But again, this is what we do when we go through these things. And it's what you should be doing when you're doing these problems before you check them here. I want it to be positive. This is what I want it to be. So that means the opposite of whatever x is has to be positive. So that would make my x negative, because the opposite of negative would be positive. So the definite, I'm going to change my definite, and I'm actually even going to rewrite it in a different color. I'm going to say the definite is that it has to be negative. Now, if you didn't understand exactly what I said here, rewind it, go back. If you have any questions, please come and see me. Okay, now what could it be? Let's go back to look at those distances. This distance here is definitely less than 1/2, but bigger than like 1/4 or 1/4. So I'm going to call that a third. So that would mean that this location right here is on the 2/3 mark. So I'm going to say x equals 2/3 right now, but I'm not done. I need to decide on that, the sign. Remember that -x means it's the opposite of what x is. I want that opposite of x to be positive, so in order for that to happen, I would need my 2/3 to be negative, or whatever number you so chose that to be. And I think I just want to go back here. I did label the others. So the answer here, this one down here is D, and this one over here is C. I'm sure you knew that, but I forgot to label them, so I went back to do that. And there we go.